Cherie Bloomfield. My student number is 3828448. The dataset was sourced from the UCI Machine Learning Repository and focused on autism screening in adults and autism screening in adolescents. Each of the datasets contains 20 features, 10 behavioural features, plus 10 individual characteristics that have proven to be effective in detecting ASD from controls in behavioural science. Both datasets have the same attributes, which are described as things such as age, gender, ethnicity, and born with jaundice. The number of rows in the adolescent data frame was 104, with the adult data frame having 704 rows. In total, the merged data frame has 808 rows. As both data sets have the same attributes, combining by rows using R-bind has been chosen as the merging method. This will take the sequence of data frame arguments and combine by rows. An index row was also created as a unique key within the data frame. The next step was to inspect and understand the dataset and variables. The data frame and variables were inspected using R functions. The dimensions were reviewed using the dim function, sampled 5 rows from the data with the head function, summary of dataset with the summary function. Each column was reviewed for the number of unique values and the content of each unique value by the length and the unique function. The classes were reviewed for each column with Sapley and Lapley function. And the data set showed 22 dimensions with 808 rows, and the class function showed a mixture of factor, numeric, and integer data types. Currently, the data set had correct data types applied. This meant that categorical columns were correctly assigned as factors, number columns were correctly assigned as numeric, and the ID field is assigned as integer. This was reviewed using the Lapley function. As an example to show how to convert a data type, the asNumeric function was used to change the integer field to a numeric data type. Within the dataset, the column relation details who is completing the test, and this was reordered so that those closest to the patient will be ordered first. The finalist order was changed to self, parent, relative, healthcare professional, others, and NA, and this was taken using the factor function. Grolman and Wickham explain a simple set of practical instructions to ensure a dataset is tidy. Each data set is in a table and each variable is in a column. The autism data is already in a tidy format as the data set meets this criteria as shown using the head function with each variable in its own column. The data set has both age and age group variables. However, the existing age groups have very broad ranges and the ranges overlap and are not logical. Current groups are 12 to 16 years, 12 to 15 years, and 18 or more. A new column that groups the ages into more meaningful groups has been created using the cut function, which slices the data into determined breaks, then applies labels to those breaks. This new column called age groups grouped the rows by age into breaks of 12 to 15, 16 to 35, and greater than 35 years. Data was checked for missing values using the isNA function. The column names for those with NA values were printed and each column was individually checked. The NAs were replaced by either using a median function for numeric values or mode function for character values. The values were then rechecked for accuracy and data types checked to ensure that it was correct. A final check of the output showed no values that equaled NA. Plotting the age variable in a box plot showed there was an impossible outlier of 383. This clearly is an area as no person can be 383 years old. The class of age variable was checked to ensure that it was a numeric class. It was shown as a character variable, so this was changed to a numeric class. Z-scores were applied to find the outliers and impute them with the average value of the age variable in the data set. A final box plot was created to check results. The final box plot showed a median age of 25 with the 25th percentile of 20 and the 75th percentile age of 33 years. There were further outliers up to 64 years, however, these were logical ages to be present within the data set. Age variance shows a right skew distribution as shown in the histogram. By applying a logarithmic transformation, it compresses high values and spreads low values by expressing the values as orders of magnitude. The resulting histogram gives a more normal distribution to the age variable. Thank you.